Okay, so this is this year's rocket that you have. It's quite an improvement probably from last year. It's much bigger and it's also Biliquid. So could you say something about the rocket and how you were able to make such a big advancement in only 1 year?
Yeah, so I guess part of the reason we were able to make such a huge advancement in 1 year was attending Euroc last year. Seeing all the other teams meant that we were able to see what we could accomplish and how to go about it, and that was like a really big change for us. To see how to put a liquid biprop system together. You will see bits of other teams' designs are echoed in this. Some of it's our own. It's just kind of how it works. If we saw a design that worked well, you know, we would use that. So that's why we went for the pressurized system, to have the pressurant push the.
You have a pressure-fed cycle.
We do have a pressure-fed system, yeah. We chose to integrate air brakes as well, because we've got some pretty enthusiastic aerospace engineers in our team, and we wanted to include some elements that would excite them, which is why we've gone for the aerofoil on the fin can and the air brake system, and that also includes a control system to ensure that they deploy at the correct apogee to try and nail that 3 kilometers. I think it's probably worth noting, saying that we're getting to get to 0 kilometers this year. We won't be flying because we had 2 tank failures during our test campaign for the hot fire, where we collapsed the inner tube of the coaxial tank. And that was a real shame, but actually to get this far in 1 year has been so immense for the team. I'm so impressed with all of them that I'm okay with not launching. I think there's many things to be proud of sitting on this table, and the fact that it's not being put on a launch rail. We'll just come back stronger and better and more excited next year.
Yes. So you're using a coaxial tank, and the inner tank collapsed because there was a higher pressure on the outside tank?
Yeah, absolutely. So we had the same failure twice in 4 days. So that was quite exciting. So this is tank version 1. This happened because the burst disc on the fuel tank went, and the burst disc on the oxidizer tank did not go. We think it was a faulty burst disc, considering that one went and the other didn't. So we had 50 bar in the oxidizer tank and ambient in the fuel tank, and we can see the result of this. The second time, we were messing around with the timings on our run valves to try and improve the ignition sequence. And in changing those timings, we basically induced a bug into our software that meant that our valves created a mind of their own. We then ran the same sequence a few times, and we got a different result each time. So that's definitely something that we need to go back into our labs and work out.